without doing any dimensions, I want to create this slider, a single cylinder engine. Okay, so let's go ahead and do that. This is a good practice for using some of the functionalities that you may have not used for a while. We're going to do this. So let's start with a product. I'm going to ignore all dimension. Notice that I can do everything in here, but this is not assembly design. I prefer to be in the assembly design. So I change to assembly design. Double gear shows up. And I'm going to save it immediately. File, save management, save as. Uh, One level up. I'm going to say, for example, here, new folder. And I'm going to say single cylinder engine. Single cylinder. I'll make it for July, July 5 lecture, something like that. Okay, so let's start with the piston. So insert a new part in there. Let me call this thing piston. Right click properties. Piston and piston. Keep in mind that you have to be organized here. There's going to be 6 different uh, parts, and you don't want to overwrite each other. Double click on the piston, and I'm going to make it. So on a convenient plane, on that vertical plane, I will sketch something that I will shaft in just a minute to get the piston. So let's go ahead and do this. We're going to draw something like that. This is going to be the cross section of the piston. It's okay. We'll clean it up. This is the piston ring. I'm going to make just one of them, not two, not more than one. Go down. This is going to be the cross section of my piston, and like so. Very good. Except that this guy I want it to be horizontal, right? Put the cursor there, right click, horizontal. Very good. And now exit and shaft it. Okay, and the only thing is that I think this is too big. So let me move this thing here. It's going to be a very fat piston if I did that drawing. Maybe this is more, yeah, this is more respectable. Exit, and then we're going to shaft it. The same place that you have a toolbar, that you have a pad, you have the shaft here. It says what is the axis? Axis is Z. Put the cursor there, right click Z axis, 360 degrees. Okay, very good. Except that my piston, I want it to be first of all hollow, and there's going to be some planes here. So let's cutouts here. So let's do the cutouts first. So on that page, on that, let me see, where is the isometric view? There. Okay, so let's make the cutouts there. So on that on that plane, we're gonna sketch. Actually, let me get out for a second. Sorry, on this plane, on the YZ plane, I'm gonna sketch. There are different ways of doing it, so you do whatever you want. Get the piston any way you want. So I'm gonna draw a rectangle here. You might wonder, why am I doing these things? You see, just bear with me for a second. Exit, and then make a pocket. A pocket in both directions. That's what I was doing it. Now I want to do the same thing on the other side so we can actually mirror this operation. So I think this is the mirror with respect to, okay, let's do this for a second. Let me cancel that. Select the pocket. I want to mirror it with respect to this plane. right there. You see this? Now I'm going to hollow it out. And hollowing out operation is shelling operation in desktop feature. You click on it. Oh, before I do that, let me actually draw my hole there, because there's going to be a hole through this where the piston pin is going to go through it. On that face, I will sketch, and then we're going to hollow it out. So a circle, the piston, the piston pin is going to go in there. So we're going to make a pocket all the way through, last, right there, goes all the way through, and then we're going to hollow it out. So here's the shelling operation. It says thickness is, let's leave it at 0.39, and faces to remove this face. And if I say okay, you see what happens. This is fine. It actually hollowed it out, except that it left this guy here. So I need to include that too. So if you go to shelling operation and also select that, it's going to take both of these out. And let me make this thing a little bit thicker, maybe 0.05, maybe. Not really, doesn't matter. Right there. This is my piston. Okay, let's go ahead and save. Please make sure you do this thing in its own folder, give it name, do not overwrite one with the other one. Click on the floppy. Okay, why don't I make the pin? The pin. So insert, a new part, call it the pin. That's very easy, it's just a cylinder. So let's rename this thing, properties, and make it pin, and pin. Okay, let's go to the pin and make it. All it is a cylinder. So on that, for example, plane, on that vertical plane, I will sketch, project that circle, okay, project that circle, and exit, okay, and pad it in both directions. And I'm going to use up to a plane, up to this plane. Did it work on the other side too? Oh, I guess I have to do the other one. So I thought that mirror extend would have done it, but it doesn't look like it. Let's try it. Okay, for this is up to that surface. For this one, also do up to plane and select it on the other side. Okay, that's going to be fine. There we are, right there. Just because I'm making these in place doesn't mean there are any constraints. We have to come back and do assembly constraints. So we go all the way to the top, all the way to the top, click on the floppy. All right, let's do the connecting rod. So insert, a new part, say no, and make it Conrad. Right click, properties, Conrad, and up here, Conrad. Let me say okay. Double click on the Conrad. Let's go make it. So on that convenient plane, on that same vertical plane, I will sketch. Why don't I project the piston pin on it? So project the piston, not the piston pin, that circle, that's what I meant. And then look at the view from the front, right there, and make the rest of the connecting rods. So we're going to draw it and then clean it up, because I don't want to spend too much time on cleaning up operation at this point. So we go up here, turn it around. Hopefully this is symmetric. Otherwise, you come back and fix it. Down here, we can fix these, and right there. Oops, we just leave it there. Okay, so let's do a little bit of a cleanup here. So this point, control that point, We're going to make it coincident. Good. Okay. So let's do this line, this circle. I think this circle and that circle, or let me hide these things so that we can see it better. Okay. This circle and that circle, I don't know whether it's concentric. I don't think they are. So this control that. Let's make it concentric. Okay, good. Very good. And then this line, control that line, uh, control the middle axis. We're going to make it symmetric. See what happened here. And okay, so let's make this center, control that line, make it coincident. If things go in the wrong direction, we go and clean it up. Okay, so one thing I don't like the fact, oh, this radius, let's see if we can make this radius bigger. Let me see. Maybe, let me make it one, see what happens. Well, the problem is that it's doing both of these, and that is happening partly because of probably that tangency. Okay, so let me do the following. You know, I tell you what, it's up to you whether you want to go and change this thing so that it looks like that. Okay, and it can be done. It's just that how much time you're trying to put into it. So let me do the following. Uh, yeah, I'm sorry, I have to bite the bullet and do this thing the way I want it. So let's try it. Let me get rid of this. I had to do it. Okay. So let me do the following. So a line from here to here, and okay, good. And then we can mirror this thing. This mirror it with respect to that. Okay, good. And then close this with a circle. How about doing it with this guy? This is the center. Goes from here, here, there. Okay. It wasn't worth it, but I did it. So hopefully this is all nice and symmetric. Yep. And then a hole at the bottom where the crankshaft is going to go into. Yeah, okay. Exit. Pad it in both direction, but not that much. Let's put down 0.2, see how it looks like. Okay, so let's bring the other guys from the hide and show, hide and show, and we have this configuration. Go all the way to the top, all the way to the top, and save it. Okay, let's do the crank now. So on a convenient plane, on same vertical plane, I will sketch. Oh, sorry. Oh, be careful. This can happen, and it's very common. So insert new part. Don't do the other part in the thing that you were just doing. Insert a new part. Right click, properties, crank, and crank. It's very common that people don't pay attention and they make the other part in the part that's already being made, and then of course things don't move the way they want. So double click on the crank. Let's make it. On that same vertical plane, I will sketch. Why don't I project the circle? Project that circle. Good. And then let's do the rest of it. Exit and pad that circle. Let me do it by, yeah, that's good. That's good. I'm still working on the crank. So on that face, I will sketch because I want to do something that kind of looks like this. Okay, and you can see what I've done. So I'm going to draw a piece of the crank, the rest of the crank, perhaps something like that. Did I project it? Yeah. Let me hide. Let me hide this because I think I projected it. Yeah. Let me hide this. Hide that. No. Exit. I thought I projected it. So let's go ahead and find out what's happened. Hide and show. Right. So on that face. Oh yeah, that's yeah. I did project and in fact I padded it. That's okay. I want to do the rest of the crank. Sorry. So perhaps something like this. And you can make it nice and symmetric if you want, but I'll just leave it the way it is. Okay, good. Actually, I don't like this, so I'm going to make that this circle, control that, make it concentric. Yeah, that's better. Good. And if you want, you can make these tangent, but I'll just leave it the way it is. Okay, good. Let's go back here and make another circle. Let's go back to that sketch and make another circle here. So another circle. Right there. Exit. Okay, so actually I want to pad this thing, but this makes a hole. So I have to do a multi-pad, which I don't want to do in this problem. Let me go ahead and delete this circle. Exit. Now pad it. Pad it. Too much. Make it 0.4. Okay. And on that face, I will sketch. I will sketch a circle like so. Exit and add it. Let me make it a little bit bigger. So what you see here is actually half of this. Don't worry about this ring. I will do it in just a minute. Okay. I want to mirror this thing. So I want to mirror this. Where's the mirror? Mirror this entire thing, this entire crank about the plane over there. So this is going to be my crank. Let's get the other guys out. Hide and show. Good. So this is what I've got here. And finally, I want to make actually the path or the base or the thing that this thing moves on. So let's go ahead all the way on the top. All the way on the top. Save everything. Insert the path. Insert new part. Or yeah, or the cylinder if you want. Let's call it no. Let's call it. This is the piston. Let's call it cylinder. How about that? Right click, properties, cylinder, and cylinder down here. Say okay. Let's go make it. Double click. And I'll do some few steps that may not be obvious to you, but that's okay. Just be patient once again. So on that top face, I will sketch. Okay, let's fit this thing. Good. Now you might say, well, why are you doing this thing? Just be patient. So we do a projection of this. Okay, circle, big circle, and then I do a little bit of a cleanup here. So I'll do a how about a center? How about a rect? How about the center rectangle to make my job a little bit easier? Okay, so maybe uh, yeah. Actually, let me do the regular rectangle. Okay, yeah. Uh, yeah. Cancel, 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 cancel. Another circle. I'll do another circle. Nope. Yeah, let's do another rectangle. Just a rectangle, rectangle. Okay, yeah. You'll see right there. And I can make a cleanup here. So for example, this line, control that line, control this axis, make it symmetric. All right, and do a cleanup here using the multipath, not multipath, the quick trim, the eraser. I want to get rid of this, and I want to get rid of that line. Okay, and exit, and uh, pad it in this direction and in the other direction. So I'll do a more, and then we go, oops, more down here. So what I'm trying to do for you is to create this, okay? So where is it? Let's do a little bit more. Good. Actually, I'll make it, yeah, something like that. And those, you see this right there? And those rings that you see here, those rings are actually where the shaft of the crankshaft is going to go into, which belong to this piece. So, for example, I do on that face, sketch, okay? Why don't I project that circle, project that circle, and then exit, or actually let's go back into it. Let's go back into that same thing that I projected. And I then add another circle concentric with that because I want to make a ring actually. Something like that. I'm sure they're concentric. Exit and pad it. Not that much, maybe point, I don't know, 0.2. See how it looks like. Yep. And then mirror this pad on the other side. So mirror with respect to the right plane. Let's look at our correct plane right there on the other side. So I have completed all the pieces. Now I have to assemble it. Okay. So, wow, that took longer than what I thought. That's okay. All right. So why don't we anchor the cylinder right there and move everything apart so that we can assemble it properly. So I'm going to move this thing in the X direction. Move this thing there. Move this thing here. And move that thing there. So these are the parts that I created. Why don't we put the piston in there? Coincidence between the axis, this not axis, but this plane, this vertical plane of the piston and the vertical plane of the cylinder. Already they are, because I translated in the x direction, already they are coincident. There's nothing to update. And then axis of this piston and the axis of the piston and the cylinder. And now when I say update, this will rush and stick in there. Okay. Now let's put a piston pin in here. So we do coincidence between the vertical plane of the pin and the vertical plane of the piston. Same vertical plane of the piston. Now this was the YZ plane. We select the YZ plane. No, cancel. I selected the wrong one. Coincidence between this one, which is the XZ plane, right? XZ plane of the pin and the XZ plane of the piston. You can see that already they are, because I translated, they are coincident. That's why there's nothing to update. And coincidence between the axis of that and the axis of this. Okay. Now, if I update, this is going to go in there. There is no problem. It will go in there. But it has the ability to spin about this axis itself. That being the case means that there's going to be a persistent 1 degree of freedom that we cannot get rid of. So what I'm going to do is I'm going to also make a coincidence, for example, between this vertical plane of the pin and the vertical plane of the piston, make them coincident. That means it cannot spin about its own axis. And this is why you will get basically it's rigidly attached. This is going to be rigidly attached to the piston because it cannot move sideways, it cannot move this way sideways, and axes are lined up, and this basically means it's rigidly attached. So let me do that here so that we don't have to come and fix this thing. So we say coincidence between this plane and that plane is the YZ plane of the pin and YZ plane of the piston, and this will make this whole thing into a rigid joint between the pin and the piston. Okay, let's put a connecting rod in there. Coincidence between the vertical plane of the connecting rod and now this one is the XZ plane of the connecting rod and the XZ plane of the, for example, the piston. And there's nothing to update because all I did was to translate this thing. And coincidence between the axis of the connecting rod on the top and, for example, the axis of, I can use that pin. Let me turn this thing around. I can use the axis of that pin and update because the pin and the piston are rigidly attached to each other. You know that. Now, coincidence between the axis of this. Well, actually, let's do it same order. It's not important. Coincidence between the vertical plane of the shaft, this vertical plane of the shaft, that is the XZ plane of the crankshaft, crank. Okay, so XZ is it XZ plane? Your XZ plane. Let's see now. Your XZ plane of this, and the XZ plane of the, for example, the pin. Not the pin. Sorry, the connecting rod. Conrod. Again, there's nothing to update because it was already there. And coincidence between this axis and the axis of the connecting rod, and update is going to go there. And now this is going to go stick into that hole. So coincidence between the axis of this ring and the axis of that shaft, and update, and there we are. Okay. Did we put everything that we needed in there? So first of all, let's go ahead and save this. All right, so if you go to move and make sure this box is checked, and we're going to rotate about this axis. Everything must move the way they are. So let's see. Right there, right? Yeah. So this is a good sign. We close it. We go and create the joints. So let's think about it before we do that. There is going to be a revolute here, a revolute there, a rigid between the pin and the piston, and a revolute between the connecting rod and the piston, and a prismatic, either a prismatic or a cylindrical joint between the piston and that uh, piston and the cylinder. Okay, so we go to the digital markup, DMU kinematics, get the magic wand out, get the magic wand out, new mechanism, 6 joints, auto create, there we are, and I bet this is going to be a single degree of freedom consisting of several joints. Yep, you can see. Revolute between the crank and the connecting rod, cylindrical. I told you between the, well that's okay. Some of these that we may have to fix. I don't know, depending on what we have done. Yeah, so let's go ahead and find out what it is. So let's see now. Let's make this guy angle driven. So that is the between the piston and the crank, or the cylinder. Sorry, the cylinder and the crank. Let's make this thing angle driven. 0 and 360. Mechanism can be simulated. Let's create a simulation. Actually, you can do that manually, but I'm going to do a simulation. Drag this thing all the way to the end. Insert, rewind, rewind, anything but one, and play it continuously. Yeah. No physics, strictly cartoon. And please keep in mind that two people may have the same mechanism, but with different joints, depending on how they proceeded in making these constraints. As long as it does what it's supposed to, it doesn't matter. If you go back to the video segment from last year, summer of 2021, in all likelihood, you get the same mechanism, except that the joints may be a bit different. Okay, and this problem was done several times in different years. Okay, this is the current one. That's what you see. I did it last year, and over the past, I don't know, maybe 6 7 years, every year I've done this thing, and every year there's a video of it that is, or not every year, but some years there are videos of it that are posted in my channel. Okay, no physics here. What we can do is that we can specify the speed of that crank and find, for example, the acceleration of the piston, etc. When you think about it, this is nothing but that single cylinder engine, a single, not single cylinder. That is nothing. It is nothing but that slider crank mechanism, but it's got a lot more into the parts that are made. Okay, anything that I want for this problem, I could have got from this slider crank mechanism last week. Good luck. Please don't wait for things to pile up. Also, make sure you save these things the right way, at least in my assessment. For example, here, look at what I've done. I created a folder, close this, a folder here, which was called Single Cylinder July 5th Lecture. All the stuff is in here. The product, piston, pin, cylinder, crank, and con rod. It is so easy to mess these up when you have 3 problems to do everything. And I've seen people doing it on the midterm. They put everything in one folder, and then things got really messed up. Okay, if I ask you to generate any plots and include it, generate only those plots, nothing more, nothing else, and do a print screen, save it in a Word document, and put your Word document in this folder as a part of that problem.